Thanks everyone for joining the monthly electrical safety call for June. Appreciate you being here. So just a bit of housekeeping. Everyone that's registered will get a recording sent after the call. Please use the post-call survey just to let us know how we're doing, or if there's anything you want included as we go down, or any topics you want in there. And we've got quite a wide network. We'll be able to get people in. If we don't have the information, we'll get people there. Make use of the chat throughout, or definitely encourage you raising your hand to be on, and we can unmute you and you can speak to give your input on the topics that we're talking about. That's where we can all learn. We don't know everything, so really appreciate your inputs as well. And then after each session, we will circulate the slides and the minutes afterwards, so you will have access to those. So again, just a brief introduction for people that haven't been on. We had a conference in October last year in Chantilly, Virginia, an electrical safety conference, and it was really good. It was so engaging. People from mainly the data center space sharing information, collaborating, experiences, and there's so much drive. And then typically at these things it ends, and we made a conscious decision to try and keep that going. And here we are. So we've started trying to have a monthly call where we try and keep the conference going. And the idea would be when we have a conference in October this year, hopefully we can reflect on some of the things that we've discussed, and then it should hopefully shape the discussions on the day as well. So we've established a steering committee. It's changing every month. So this is typically who is in here, but it is always changing. Range of experiences there. And then this is how we want it to run. So we'll have a 1 hour call every month. The committee, we will meet on an interim call to discuss how things are progressing. And then we'll hold this call where we will have a look at a safety moment, because it's really important to get that information out there. If it's happened to one person, it's likely there's potential there for it to happen to somebody else. So often these things stay in silos or in departments or within an organization. So getting them out there. If anyone on the call has got something they can share, they're willing to share, even if it's anonymous, we can go through an NDA process, strip it back and present it just to get that information out there. But we will cover a safety moment at the start of each monthly session. We'll recap the work streams. The volunteers in the community will typically present their inputs on there. Then we'll open up to you guys in the community for your inputs, whether it's related, good, bad, and different. If it's not relevant in your field, or if you do something different, they're all things that we can learn from, and as a community grow together. We'll review that each month, and then we will be starting to work towards the 2026 conference, which is in the same location in Chantilly, Virginia, in October 13th, Ben.
13th.
October 30, lucky 13. And yeah, so what we want to do is with that, then bringing us on to the next topic just before we make a start. It is a 1 day event, and the whole purpose of that is we're going to be focusing on the guys that are doing the job. So the people that are in front of the equipment, operating it, maintaining it, the people that are subject to that risk more than the ops managers, the safety managers, things like that. So we'd like to get some of your stories so we can start using that as part of the conference to form the shape of that. So please, we will follow this up, but what I'd like you to do is take this away yourselves or to your workplaces. We'll put some information out to market it, but we want your stories from lessons learned that come from your experiences, either good ones or bad ones, or near misses, what's gone wrong, what's gone right, your everyday challenges, what you strive with all the time, success stories, and it will help us shape the conference. We want to get your voices heard, and it might learning us like how we deliver the day, the content on the day. So we will follow up with some information on this, and then we'll probably put like a link out to you guys to share with your organizations. Right, so it's my turn to share a safety moment this time. And this is from something that one of the recent conversations I've had with one of our clients. So the incident itself is it's in an industrial environment, and one of the technicians on shift has gone to isolate a 400 volt local isolator at a panel. Following a normal process, they don't always work in that area, but they've worked there in the past, so they've got a little bit of familiarization. The technician's gone to the equipment, located it, checked the single line diagram, rotated the rotary isolator, um, and then they've applied the lock and tag at the equipment. It's only a single isolation. What the technician then removed the cover from the junction box, and using a potential indicator, they've then done the live dead live process and proven dead using that potential indicator at the point of work. Um, when they've done that, there was no indication, and the test instruments worked, so all good. The process has been followed. The tech had a gut feeling when he was telling me what had gone on. He just said it didn't feel right. Even when rotating the isolator, you get a feel, your experience, you get a feel for how things, whether it's a circuit breaker or an isolator or a switch, you get a feel for how things are. And what he said was when he'd rotated the isolator, it didn't feel as he would expect, but he just overlooked it. And he had a gut feeling. So he just said he removed the cover from the isolator to prove dead at the incoming terminals. And as he's proven dead there, he's done the live dead live process, and he's discovered that they were also dead. So he's thought, what's gone on here? I've got no supply at all to this. Obviously for the work he's doing, he's he wants no potential energy there, but this is also now grown into something else. Whilst he was there, because he had a gut feeling about how the isolator felt, he wanted to try and prove effective isolation across the isolator. So just a continuity check from one side to the other. When he's done that, it should have been open circuit because he's rotated that isolator into the open position. When he's done it, it's actually he's still got continuity through the isolator. What he's discovered is as he's rotated that isolator, it's just rotated on the spindle. So it must have been worn or brittle where it's been on the spindle, and it's actually has rotated. There has been a little bit resistance, but as he thought, it's not as expected. You haven't got that little bit of tension to overcome. So essentially, that wasn't isolated. That was still a closed circuit there up to the point of work where the person was going to work. He's then followed the cable back, because again, it's not right. Why he's got no potential. Why he hasn't got 400 volts of those incoming terminals. When he's got back, he's seen that the supply has been moved to an auto transfer switch, and it's now on a secondary supply, which it just pulls in as part of the process. So it had been done by another shift for like a reliability improvement, a small project done within the shift, and no one had been communicated to, and the single line hadn't been updated. So potentially he could have done that rotary isolator. He could have been working at the point of work, and then that transfer switch could have then changed over to that supply, and that would have been straight onto the point of work where the guy was working. So that was classed as a near miss on this isolation failure. So the big things in the root cause analysis was that the change management process hadn't been followed. It had been done because there was an incentive in each area for them to make these reliability improvements to improve single points of failure, things like that for the process side. And so people have been doing these things and just kind of banging them out because that was an incentive that was in place, but they hadn't then followed through that change management process of the plan, do, check, act. There was no communication to anybody. The documentation, I mean, we cover this on most of these. The single line diagrams or the one lines not being updated. And the live dead live process was followed, but it would have been a false indication anyway. It wouldn't have been effective if that transfer switch had come in. Yeah, and that's pretty much it. I mean, has anybody on the call had any similar experiences to this? Thanks for that call. Not functional. All right. No one's got any similar experiences that they want to share. We'll shift on. Right, so work stream one, which is the commissioning, transition, and turnover. I will throw you over to Alan, if that's all right, Alan, just to talk through where we're up to with this. I don't think it's been much change, but
Yeah, there hasn't been much change on the the turnover to operations, but if there's anybody that wants to work on a checklist and have anything review, I'm happy to review somebody's and provide input.
Yeah. So we've got the big thing with this, I think, which Wayne was working on is we went through like an overview of a commissioning checklist for that to make sure everything's captured before it gets handed over. But it was quite top level, so which is where we started. We've started top level because we know it's an issue, and then now we're starting to work down. So suppose what the call to action is, if anyone, what's going on in the background is we're gathering examples that people use for their electrical equipment, with this being relevant to electrical safety. So commissioning of electrical systems. So some examples of there of like HV or MV, switchgear, transformers, things like that, to create individual equipment checklists. So if anybody on the call has got some that they think are good, or they like them, how they work, what's included in there, be really grateful if you could provide them again for review, because it's we're just working in isolation here. Obviously everyone's got their own good ideas, and some will be better than others. So it'll be good just to try and pick good bits from all of these standards and come up with a better one that we can, people can have there as a template, and they can just take out or add in bits that they need to as they go. But at least everyone's not starting from scratch. So if anyone has got anything like that, yeah, we'd appreciate that being provided if you're willing to do that. All right, work stream 2, which was around unified energy control plans, so mainly around lockout, tagout, and energy control plans. And it was picked because we have those discrepancies from the start to finish point between construction lockout, tagout, different contractors working and doing their own thing, commissioning lockout, tagout, and then once it gets thrown over the fence to the operational side. So the aim of this was really to try and identify gaps and try and align best practices. So the bits that have been looked at so far was Wayne took us through his process, how he checks different electrical safety programs that are going to be working on the project to make sure that they're equal to or better than the company's expectations. And then at the moment, we're just looking to try and get some data around how we manage those effective boundaries between whether it's partially energized, fully energized, parts of the network that then get put over to operational sides. Has anyone got anything to add on that from the committee? That's fine. So work stream 3, we're looking at electrical hazard management. The purpose of this was because of the risks that was posed to through inaccurate, outdated arc flash studies labeling throughout the whole life cycle, really from the start to finish. But we've also captured electrical hazard management. I've left in there about PPE policy and standard, because as part of this process, on the last call, we shared a draft arc flash PPE policy and standard, which again, it's not commercial, so it's not linked to what we provide. It's what a lot of us in the committee have worked on, put together recommendations based on some of the things that you'll find maybe procurement might buy a cheaper option like treated fabrics. It might not be certified in the right way. It might just conform, that sort of stuff. So we've put in like a list of recommendations that we would expect to be in a standard. We've kind of done that as a bit of a collective, and that should have been shared after the last call. But I will follow up after this. Really, we're just trying to get some feedback. It might be easier to make it a local standard than what it would be a global standard. But essentially, we were trying to just have a baseline expectation so that any company can provide that to either project staff, if they're outsourcing, or if they're even going to go out to tender for their own PPE for their own workers. At least they've got a minimum expectation of what they should have in place to make sure that their personnel are correctly protected from the hazard of arc flash and electric shock. We've just shared it with the Data Center Safety Council for them to have on their last call as well. And then we're just waiting on feedback from all these sources. So if you have seen it and you can provide feedback, great. If you haven't seen it, let us know in the chat and we can try and just get it back out again, because sometimes we don't know if it's been successfully delivered. But yeah, it'd just be good, I think, to have an overall standard there. And then on these ones, Cody, I don't know if you want to give us a bit of an update on where we got up to with those?
Yeah, of course. Hello, everyone. My name's Cody Fleming, Aligned Data Centers Electrical SME. I've been working on how to determine basically accountability throughout the construction process and then following operations for our flash labeling, making sure that we have the most up-to-date information and people are staying safe. So we, in the beginning, I kind of thought maybe like a one-stop shop, one-stop document. However, I've kind of done some digging and I've gotten with my peers on the construction side, and I've noticed that it's probably better to spread it out. So instead of making one singular policy that says, hey, follow these rules, we've kind of spread it out into all of our CX scripts, all of our safety aspects. So anything that touches electrical, we're focusing on verify, like during construction, verifying that the arc flash label is correct against the current SCCS. The one major challenge that I'm still facing, and I'd be love to hear some input from everybody else is that the EORs, the engineers of record, may or may not make a change, and that may or may not get communicated to the construction team. So if anyone is having that kind of issue where the EOR is not communicating well, it can be difficult to maintain that accountability and process when the person who owns the study doesn't actually tell you what it is. So looking forward to giving you more detailed information next month. We're going to be getting it all into one, and that way we can all reference one document and it'll tell you all these other documents to check.
I appreciate that. Thanks very much. And I think that's kind of where we're up to on the what we'd like to, because we're trying to work towards. We've been kind of working on these different work streams in this at the start. The whole point in this, in carrying this on, was to continue the conference essentially. So we have been getting some bits of information in, but we've been trying to work on it practically in the workplace. So what we're going to focus on today, just to start bringing it back towards the topic of the conference. We've got James Hammond from IPEC, who's going to get us up to speed with partial discharge and the links to electrical safety and reliability. We touched on it briefly in the conference, and it got quite a lot of traction. People wanted a little bit more information, which has been something on the list we wanted to provide in one of these. So I'll now hand you over to James, who's going to give us a bit of information. I guess if anyone's got any questions, James, you happy for them just to chip in?
Yeah, happy to on the chat, or if they want to just unmute their mics and speak, happy to answer any questions they have.
Perfect, thank you.
Perfect. Shall I just share my screen now?
Yeah, just go for it.
Perfect. Okay, can you see that now?
Yes, now we can.
Is that sharing? Is it sharing full screen?
Yes. Did you have your sound on?
The sound is on, yeah. That's for the important buzzing. All right, well, thank you very much, Dan. Yeah, so as Dan said, I'll be talking just briefly about partial discharge, what it is, how it can be detected, things like that in, I guess, in preparation for the conference, where it was, quite an important part of electrical safety and prevention of any sort of failures. Quick introductions. Dan said I'm James Hammond, Regional Sales Manager of IPEC. And yeah, I'll just give a quick introduction as well to IPEC as a company, just so I can give our credentials. So yeah, we just celebrated our 31st birthday from the University of Manchester, and do online PD monitoring, PD testing, and one of the world leaders in actual assets covered. With one of our main priorities is R&D and technological advancements, which is why we've gained quite a bit of traction globally. It's quite a niche market, admittedly, partial discharge, and it requires quite a lot of technical knowledge to be able to do it properly. Bit of news just to update about IPEC as a company. We've actually just been acquired by ABB, so we're going through a bit of a strategy change, going from blue to red. Some of Manchester City fans won't be too thrilled about that, but we're getting basically getting a large amount of investment as a lot of the market is heading towards PD. So just to get everyone on the same page, I'm just going to quickly go over what partial discharge actually is. So this here is the dictionary definition. So an electrical discharge that does not completely bridge the space between two conducting electrodes. It's essentially a small spark. That's how I think of it anyway. A small spark that is constantly damaging, corroding, breaking down insulation if there is any type of defect. And that defect itself, you can see here an example on just a cable. This can be caused at factory. It can be a defect in insulation in the bus bar sections, in cable terminations, any sort of change in medium is how I generally think of it as well. And what this defect really does is it actually generates a area of electrical stress concentration. So here's like a simplified version of that cable with your HV there, your earth, and a defect. And basically over time, this partial discharge is happening, 60, 50 times a second, depending on your frequency, and slowly damaging and breaking this, or I say destroying this insulation. This is my animation of it damaging it over time until eventually that cavity can no longer protect or no longer be insulating enough in order to act fully as an insulator. And what you get then is a failure, an arc, some kind of fault, which will eventually lead to an unexpected outage a lot of the times. So the PD itself tends to happen in phase with the power cycle. So what you have is on the rising and falling edge, you have these partial discharge pulses. If you've ever seen any graphs like these, they're known as PRPD, or phase resolved partial discharge patterns. And what these are these discharges happening on that rising and falling edge of the AC sinusoid. And basically, this is just where that certain threshold is breached of the voltage, certain threshold is exceeded, and then what you have is these discharges occurring locally. And as you can see, it's in line with that phase, so 50 or 60 times per second. These are obviously theoretical, but over here on the right, you can see real data, and you can see it lines up quite nicely. So luckily, from the research, it turns out to be quite true. And this is just some examples of patterns. I've just brought these up because I've got some examples of PD actually being detected, so you can see what it actually looks like. But what you see generally is groupings of these electrical discharges 180 degrees apart. So like I say, on those rising and falling edges, and you can see it here. So you can see that grouping there and there, 180 degrees between them. And that's something that was very common in the PD detection world. Some examples of actual PD that you might see in the field. On the left here, we've got actually an internal PD. Obviously, this you're very unlikely to actually see something like this, but this is what is really going on inside that void. So I showed that expanding white square. Realistically, that void isn't growing like that. What it is small electrical trees, growing very small amounts, less than millimeters each pulse, until eventually that insulator is completely non-insulating. You can also get things like surface tracking and carbonization, so you can see visible. Some of you maybe in switchgear may have seen this. And if you've been into a switch room, I guarantee everyone's seen this white powder, this nitric acid deposit. This is actually a symptom of partial discharge. What's happening is you get a breakdown of the nitrogen in the air that forms a precipitate on the surface of the insulator. And this is bad for two reasons. One, you've got a corrosive acid, basically, on the surface. You've got evidence of PD. And then, I guess, thirdly, this is actually an accelerant. What this does is this creates an area or a position, again, of a different medium, generally more conductive than the insulator, which can then promote or exponentially increase those PD pulses. And this PD is, it's damaging this insulator mechanically, thermally, and chemically as well. And it's a very common reason for failure. It's on average about 80% of failures or HV failures are caused, or at least have the root cause being partial discharge. And that's mainly because it's invisible. It's only detected once you've got the instrumentation, or if something catastrophic happens. That's the only time you ever find out that PD was ever there at all. Because generally these switch gears, they're closed. They're rightly so. They're kept away and left running. For in the UK at least, we've had systems that are getting on 70 years old, and where we have equipment. So it's something that is growing over a period of time that's invisible. And it grows as well. It gets worse and worse over time, and then eventually you do get that catastrophic failure. And again, this catastrophic failure is normally, unless there's some type of monitoring equipment and some sort of maintenance regularly undergoing, where you can actually get inside the gear, it can be completely unexpected. A couple of examples here of some pretty bad failures as well. You know, like I say, it can be various types of assets, various locations, and some can be really catastrophic. Some can be hidden in the background, leading to failure. This one actually was detected before anything catastrophic occurred. But as you can see on the left-hand side, some actual devastating results from the PD. It can be detected. This is how it's detected. So this little electrical spark is generating energy. So it can be a form of a current pulse. A couple of examples of how that can be detected: a HFCT, TEV. I'll go into these a little bit more in a second. It can be an electromagnetic pulse. Again, electrical energy. You've got that electromagnetic pulse generation. These can be detected here. There's in the ultraviolet range, in the ultra high frequency range, things like that. And then acoustically as well. Often this is in the kilohertz, so like 40 kilohertz is where it's most common or most easily detected. However, if you've been into a substation, been under a power line, of course, you do hear that buzz, which is very recognizable and is an evidence or example of partial discharge occurring. So bringing it back to actual reality, something like a TeV sensor, a transient earth voltage sensor. This is detecting this movement of electrons, that current pulse. So say if you have this partial discharge occurring here, what it does is it emits the energy and these electrons get transferred or pushed, or basically they move around the metal surface, sort of on the skin, I guess, of the metal clad surface, and then induce a voltage onto our TeV sensor. And then same method in cables as well. You get that movement of electrons, which then travels down the earth, in this case, where we put our sensors, and again, induces that voltage. So then we can detect this partial discharge. So for acoustic, again, what we do is we basically simply just put a microphone. If you have your bushing, in this case, PD on the surface, what this does is emits the energy acoustically and can be detected by the microphone. And then if you have a different type of sensor, an ultra high frequency sensor, that same pulse of energy in the ultra high frequency range can be detected that way as well. So just going through a couple of the installations of what it would look like physically. So you can see here your HFCT around the earth sheaths of the cable. You would have an acoustic microphone pointed at the terminations, often where you get your surface partial discharge, and then a TeV sensor on the metallic cladding as well to detect those current pulses that way. Something like a dry type transformer, again, detecting surface tracking and TeV signals on the outer cladding is a method that we use. And then in oil field transformers on the higher voltages, in transmission level, often where there is hopefully DGA going on, or some type of testing anyway, but we can get right inside the oil itself using a drain valve sensor, and what you can do is you can detect PD that way as well. And then here it mentions HFCTs. So HFCTs can be used in quite a few applications as well. And then if any of you are in renewables, we find that a lot of new gear is generally gas insulated, especially MV gas insulated gear. This has been notoriously difficult historically to test, mainly because the actual cabinets themselves are completely sealed, hermetically sealed. So getting a TeV signal, out of there can be quite challenging. If you look here, there's small gaps in the cladding, but something that's hermetically sealed can be quite difficult. So sensors can be used there as well to plug directly into the existing VPIS, VDIS, whatever you call them, but the voltage detection system ports, they can be used as well as a method to detect partial discharge. And just to give you a quick visualization of what this would look like if you were to see PD being detected. So I'll just play these videos. So hopefully you can see the TeV signals basically placed on the surface of the equipment, and then you get that grouping, as I mentioned at the beginning, of partial discharge patterns. And this is a quick spot test as well. And then something like an acoustic emission, you can see this engineer here is testing on the rear panels of 13.8 kV AIS. And then again. And again, you can see those patterns building up 180 degrees apart. So yeah, a couple of methods to how to detect PD, and basically all assets can be monitored in some way. You know, with our sensors, other companies' sensors, whatever it may be. The sensors are really not that the interesting bit. The sensors are just a method to detect that current pulse, that acoustic energy, whatever it may be. Placing a sensor is that first step, and you can see any asset there has some sensor that is associated with it. So why actually carry out the PD testing? One thing is it's condition-based maintenance. Is we're moving away now. The market's shifting, rightly so, really, moving away from time-based testing or time-based maintenance and just going, oh, this asset is 10 years old, it needs to be tested. Everything's trying to be more optimized and slimlined, and keep reducing costs. And this is one way to do it. Getting that real-time asset condition and knowing there's a problem based on the condition itself is much better than just waiting for a certain length of time to have passed, because then maybe you find that an asset that might be new that has this PD needs more attention than an old asset that doesn't contain or have PD. You can also schedule maintenance as well. Optimizing scheduling is also a huge thing. Again, bringing those costs down when it comes to manpower in places where obviously salaries are increasing. Engineers are expensive, rightly so. We do a great job. And optimizing this maintenance scheduling is very important, and focusing on assets that actually need it, as well as critical assets as well. If you find an issue on an asset that is controlling, I don't know, air traffic control, for example, that might be more important to address than maybe a small residential community in the countryside. You know, I think that's might be unfair to say, but I think that's the truth of it. It also increases that uptime as well. What it's doing is reducing these unplanned or just outages in general. If you know the health of your assets, you can make changes, you can plan maintenance, you can make sure that that failure or that fault doesn't turn into a catastrophic failure, which massively increases the actual uptime itself, rather than running risk of unplanned outages and trying to get engineers from different parts of the country, different parts of the county, wherever it may be, to make these repairs. If you can plan for it, then you can prepare for it, and then ideally you can prevent it. There's also a lot of external drivers as well. You can see a few marked here. The occupational OSHA it pushes towards PD testing, and again, keeping engineers safe. One of the most important parts of PD detection, really. In the UK, we have the HSE, again mentioning partial discharge. As well as this, we've got standards, IEEE, IEC, SEGRE. I've put on as well for this one the NFPA 70B, a huge, kind of a recent change in the last 3 years, going from an advisory to now a mandatory standard in a lot of cases. And as well, we see a huge demand as well in the insurance industry as well, basically requiring PD testing to actually be carried out. It's always worth checking policies for this kind of thing, because sometimes it can say they can completely void insurance if PD is not being tested, because it should be a method to understand the asset health. You know, it's similar to a getting your car checked or getting your tire pressures checked. If that's not being done, then there's a chance there could be further faults or damage that in some cases insurance companies wouldn't cover for. And just to go on and mention a little bit more about the NFPA 70B, as I mentioned, this is now as you're probably all aware, this mentions quite a few times in the actual standard itself as PD being one of the permitted tests for high voltage and low voltage assets, actually lower voltage, and it's a mandatory part now, a mandatory standard. It's important that this is carried out in some way, or some type of insulation testing is being carried out. Okay, so what it is it also, as I mentioned before, it is that scheduled maintenance, and that can be done by testing, spot testing itself. Basically finding out the health of the asset. Does it need repairing? Doesn't it? Predictive maintenance, finding faults before they actually occur as well. So this could come down to PD location, finding where it is within the gear, within the network, maybe even within the cable. And then finally, this condition-based maintenance. So having a complete understanding of the network and the assets by providing that full PD monitoring. And then as well, this level of protection can be chosen. It doesn't always have to be the full end or the bottom end. It can be somewhere in between, a hybrid. So something like periodic monitoring, as I mentioned, spot checks. Again, this is using the condition of the asset to make these engineering decisions. So using a handheld device to get that instantaneous PD level is one way you can, protect your assets. You can do investigations as well, third-party services to carry out surveys, PD locations, verifications, again, reducing that CapEx. And then that continuous monitoring, that permanent side of having something installed, that full robust asset management to understand exactly where all this PD is happening, the threat of it, the risk of it, etc. And then mainly this can be, a lot of companies out there, IPEC included, can be for greenfield projects as well as brownfield retrofits. It's very important that there's no, just because it's a new asset and it therefore doesn't need monitoring, or if it's an old asset, it therefore can't be monitored. The main point is any greenfield, brownfield, new, old, whatever the condition, there's always a time for getting some PD monitoring installed as well. Okay, I believe that brings me to the end of my time. I don't know if anyone has any questions. If they want to unmute or pop them in the actual chat.
Got some interesting points there, things that I come across quite a bit. One of the points is, a client that I'm supporting at the moment for a switchgear installation, and they've opted not to go with the permanently monitored sensors because it's a new board, and as that's your choice, but based on the criticality of it should be formed a risk assessment. Is it critical? Who's working around it? That sort of stuff. Then a decision made from there, because it's so much easier to put on in the panel shop. That's my point, is from a design side, it's better to put on when it's been built up rather than 5 years, 10 years down the line when it's actually in operations and you've got to take like individual feeds down at a time, plan the downtime in retrofitting. It's more costly, takes more risk, takes longer, that sort of stuff. But yeah, it's really good point. That comes up quite a lot.
Yeah, definitely. Yeah.
What's that factor, James? The difference between being able to put it in beforehand and afterwards?
So when you say factor, what is it that you're referring to as factor?
Factor as in, is it, twice as expensive? Is it 4 times expensive?
It depends on what the asset is powering, I guess. It's just requires maybe some short amount of downtime. Often, if this is scheduled, and not an unplanned outage, then it can be no impact at all. Having it retrofitted is actually where IPEC has been doing most of its installations. Only recently, in things like data centers, where they want to, prevent the life of the assets completely from start to finish, is where we've seen a bit more greenfield sites, if you will. So there's no real issue unless that downtime itself is extortionately expensive. And even still, a lot of these sensors can be installed externally as well.
No, that's good. Yeah. I think a big thing as well that I've kind of seen is when you're presenting to clients or trying to educate on arc flash like causes, you've obviously got the obvious, like human factors, shorting out, direct shorts, things like that. So where it's intrusive, people are involved. Environmental conditions is typically a hard one to, if you kind of sit through anybody's sort of educational pieces, training and things like that, actually showing someone an environment inside of a bit of switchgear or a transformer where it's there's a lot of debris or dirt, dust, that sort of stuff where you can see evident tracking. You don't often have many pictures of them because you normally don't get to. You normally find out about it when it's catastrophically failed. So when it actually flashes over. I had a couple of examples in Indianapolis actually when in a site out there where their maintenance frequency was I think 5 years for the assets that they were maintaining, pad mounted transformers, things like that. And within that, I think the 3 year they started doing these PD assessments, and two bits of those bits of equipment, they were getting high levels of partial discharge. So they planned the downtime in, took it down obviously in a planned way, and that's what it was. The whole environment around there changed conditions. So from what it was like before to what it was like after, and they'd been getting an increase in debris from adjacent roadways and things like that, where they changed the nature of the traffic, things like that. And you could see the tracking, where it was. So I'm a big advocate for PD testing.
Yeah, definitely. And those environmental conditions are a huge factor as well because they're changing constantly. I've done PD testing in certain times of the day, and it's changed. It's different than it was because there's so many impacts of external factors that cause PD to increase. Could be humidity, temperature, as you say, particles, dust. A lot of our installations are actually in Saudi Arabia, where there's obviously a huge amount of sand, dust particles, and we see quite clear correlation between areas of higher dust or wind activity where there's a lot more sand, and then higher partial discharge. And again, coastal where there's salt in the air, things like that make a huge difference that you only really know once you start actually doing these tests. And then from that data from the tests, you can then plan accordingly, which again is one of the main points really.
Yeah, no, really good. Has anyone got any questions for James whilst he's here?
Carl's been allowed to speak now, so Carl, whenever you're ready.
Sure. So this comes from a former employer that was down, well, two plants. One was in Chile, the other one was in North Dakota. What we found is that the splices and the splice kits met all the specifications for engineering, but they could not actually be installed with the workmanship and quality engineering in the field because of, in Chile, it was the amount of dust that was in the area because of just all the really fine silt particles that was in the air. They couldn't get it clean enough. And then in North Dakota, because the freeze thaw cycle, just it put intrusion into the area. So we ended up with complete failures in a whole bunch of the underground splices. And so once we experienced the first failure, okay, that's a one-off. Second failure, okay, that's start of a pattern. Once it got to the third one, it was okay, we need to figure this thing out. And so partial discharge was able to determine which ones were in the greatest need of immediate replacement, and then you could schedule downtime. Same thing happened up in North Dakota. Again, what it enabled us to do is to avoid the cost of availability hits, because on the electrical grid, you have to generate or else you get fined. So you don't have an option. Now, I assume data centers are basically the same thing. You can't go down. So even if it's going to be bad news, having the PD results and we also use VLF at the same time, combine the two testing protocols at the same time to be able to get a good picture of it and then to be able to schedule it. Yeah. So that's in my experience. It's well worth it. And then if you can put it into new gear at the start and be able to monitor it again, it just helps you get uptime. If you're in that space where availability is at 4 nines or 6 nines, you don't have an option. You have to get the information, or otherwise you're just rolling the dice. That's all I got.
Yeah. No, definitely. I think it's a huge point. It's that it's having the information at hand is what, everything's so data driven now. And it's so important to actually take the data that you've got and then make amendments or make those fixes accordingly based on that. So yeah, no, cheers for that. Just reading Anthony's has left a message. But yeah. So Anthony is also saying that retrofit solutions tend to incur higher costs, introduce complexity, and yeah, this is true. It's one of those where we say exactly. Yeah, customers often show limited interest in these systems until they've had a problem. This is something we experience a lot. Often we end up getting calls and fit solutions once they've had a recent failure or once they've had a test that comes back a bit scary. In an airport in the UK that we monitor, they'd had testing on their cables that go into their, again, air traffic control that goes right under their runway. And this is exactly the problem. They got a VLF testing and they go, all right, okay, this could be a problem. If this goes unexpectedly, we've got two issues. One, the air traffic control is down, and two, we've got to dig up the runway. So we now monitor their cables online, and basically, turns out it wasn't the biggest problem as they first thought. So it's able to make sure that they can plan accordingly, and if that is the case, they can route around. And some decisions that they've made from this have been because of the results found on the PD analysis. But yeah, it's a very good point, and it's exactly what we experience as well, Anthony. So that's quite funny.
Not to the person that has the downtime.
No, of course, no. That's it.
No, that's good then. I appreciate that. Thanks, James. I think we've got some really good information. It just helps because there was lots of questions at the conference. We didn't really get a chance to cover them all. It's busy, isn't it? It's just you're back to back. So hopefully that's answered some of the questions that were out there as well.
Yeah, I mean, if there's any more as well, get in contact with obviously yourself. I'm sure you'll pass them on, or IPEC. Any other questions we help quite a lot of just general inquiries for just PD in general. So yeah, always happy to help or provide some answers if I've got them.
No, perfect. Thank you.
That's one.
No, it's appreciated. So just finally then on workstream 4, which covers the contractor and companies management side. Again, this is they're all big topics which we'll probably talk through for years, but this was picked just because of the skill gaps that we're seeing in the levels of competency, which all link into the other themes around keeping people safe. So we've got a few actions there on the workstream 4 side. The big thing was about gathering data. Jose, I don't know if you wanted to give an update of this, or are you happy just for me to say where we're up to, or do you want to do?
Yeah, either way, but I can jump in real quick. So yeah, we put out a data center electrical incident survey, and we got a few responses, and we're still waiting on a few other responses. But then, like things do happen at data centers, we lost that data, and there is a backup, but it's not the most recent backup. So that being said, we're pivoting, and we're gonna probably put out another survey and give this a fresh launch. So be expecting a updated survey. If you guys know who we could send that to, that obviously helps. If you've got the information, that's great, but most people don't have this type of incident data. So that's kind of like one of the first hurdles is, we have a survey, but we don't know exactly who to give it to and who could give us the best kind of information. That all being said, any information is better than no information. And it's not exactly like we're looking to grade anybody. We're not looking to grade the industry. We're not looking to grade companies. This is all just general metrics that we're trying to gather so we can all say we're looking at the right problem, because it is a problem, and that's kind of what we're trying to start from. I've got a gut feel. I mean, I've been in the industry since 2009. I've got a gut feel of what we should be working on, but I'd rather not just be my personal opinion, the Joe Show, and I'd rather it be everybody's contributions, because in the end it's going to be provided back to you, and you're going to have to run it at your site and your facility. So that all being said, Dan, I think we're pivoting to put out a new survey, and that should be out shortly, probably with the stories from the field link and URL.
Yeah. No, that's perfect. Yeah, exactly that. We're just going to use a system that, again, it can be anonymous. You can add on that if you wanted to, and just give your information. It's up to you, but really it'll give us an opportunity to make sure we're on the right path. And if we could possibly use it down the line to benchmark, if you wanted to, rather than just be siloed. Yeah, I think we're good, or I don't think we're good. But what are we like compared to other people in industry? Numbers. It might give us an option to compare, like do an anonymous comparison to go, out of 80 sites, we have this many instance near misses, that sort of stuff, to give a bit of a benchmark to see where you are, which I think is always good. It's really hard to benchmark in any industry. So, yeah, no, brilliant. Thanks for the update, Jose. Appreciate that. Yeah, so as he said, we need the information to do that. So we'll follow up with that to kind of build that information around those types of incidents that happen in the workplace. And I think we're pretty much there. So I'll just we are heading towards the conference in October. I think has it been launched now, Ben?
Yeah,
on the landing page. Yeah. So we've it's October 13th, Chantilly, Virginia again. So pretty accessible. It's really going to be focused on the guys on the pointy end, the people doing the work, rather than, I suppose, the systems around that. So if anyone's wanting to be involved, let us know, but it would be great to have you there. We'll follow up with more information as things progress, as we start building out the agenda and things there. But yeah, these stories from the field are really key. We want to start getting those involved. I started just putting the question out, Jose, back here, just around sort of getting a bit of a feel for that, and it's already kind of gone into tomorrow actually. We thought it just whilst the iron's hot, doing a podcast, which I never thought I'd be doing. This like only last year I was kind of throwing breakers and things like that, and now I'm going to be doing a podcast tomorrow. But it's a guy just come forward and gone, I've got this experience, and had a conversation with him, and it's so relevant. It's something that he done, something happened, and obviously he's been impacted by it, but it's something that's repeatable. It's foreseeable that it could happen in any other environment. And I think often you don't get the opportunity to talk about those. So any of these things, they all shape like how we work together and get the information out into the community. So yeah, anything like that is appreciated, so we can get your experiences, good, bad, and different, and help them form part of what we're trying to do, trying to push the needle. Yeah, well, is there anything else in the chat, Ben? If there's not, we'll thank everyone and let you go back to your day.
Anthony, you've just put something in there. Not a chance to read, it's just come through now. I can quickly read this out if you want.
Yeah, go for it.
Anthony's put here, I've got concerns regarding the authorization process, specifically around the gap between gaining authorization and having the competency to apply it safely. For example, individuals can complete National Grid competent person training and be authorized, but this does not necessarily mean that they have sufficient knowledge or experience of the specific equipment or assets involved. As a result, they may be in a position to hold permits for work on systems where they do not fully understand the associated hazards or risks to the working party. This creates potential safety risk, as authorization alone does not guarantee asset-specific competence. Greater emphasis should be placed on ensuring that individuals not only hold the appropriate authorization, but also possess the necessary practical knowledge and understanding of the equipment they are responsible for.
Yeah, no, that's an interesting point. Do we get emails on here, Ben? Because I was going to say it'd be good probably to catch up outside of this, because just to see what not what industry it relates to, but because we get
I get transcripts and everything. So
yeah, because we get in some industries it'll be to a geographical point on a system, location, network, that sort of stuff. So you maybe a competent person, so you can receive a safety document on equipment that you're familiar with, that you understand. Whereas a lot of in the utility side, like you've referenced, it might just be a voltage range. So you might be a competent person up to 11 kV for a under a set of safety rules. So it could be anything within that voltage range on any of those site locations that you're then receiving a safety document for. So I agree, that there are a range of different equipments out there. So it could be like, fixed pattern switch gear that's really simple, or you could have some really aged switch gear, oil filled with lots of quirks, worm gear and VTs and things like that fitted into it that again pose different risks to people that are working on the equipment. So I'm happy to follow up with Anthony just to get a bit more context and maybe loop it back if that's all right into the next meeting.
Yeah, good. Carl, have you got your hand up again? Sorry.
Yeah, just keep in mind in the United States, under OSHA, there's two different sections that apply. But even if you have somebody that presents certifications or has whatever document behind them, you still have an employer obligation to ensure that they are competent in the context and the risk of what they are working on. So even though OSHA doesn't enforce it very much, they occasionally do, and they hit you pretty hard with it. So from an owner perspective or from a contractor perspective, you have a duty and obligation to ensure competency for that person working on that equipment with that particular risk profile, and not a universal, well, they got their card and they're done. Hard standard to meet. It's really foggy and vague, but when it comes to fruition, it's pretty serious in the U.S. You end up with a serious and a willful, and that's a lot of money, and it's also a bad reputation hit.
Yeah, definitely. Yeah, thanks for that, Carl. Appreciate that.
I think we're all good in the chat now.
Brilliant. Well, thanks very much. Thanks very much, everyone, for attending. Thanks to IPEC for giving us that bit of information there. Hopefully, it's bridged a bit of a gap in some of the questions that cropped up in October last year. It only feels like it was last month, but yeah, and all of this forms towards the next conference. So if anyone wants any information as well between now and the next session, just get in touch. But yeah, thanks again, and enjoy the rest of your day.